Okay, year 12, we are on to pages 15 and 16, steaming ahead. I hope you are keeping up with the work that I've posted and you're trying your very, very best to make progress in your graphs booklet. Okay, now what I'm going to do here is I'm going to explain the way in which we get the graphs, the equations for graphs 1 and 2 on page 15. Okay, this hopefully will tie up with what we discussed in lesson the other day or yesterday. Okay, now let's look at the first one. I've sketched each graph very quickly and brought out the main points of each so that there's no graph paper to see because I'm using the main points that are necessary for finding its equation. Well, we have here a parabola that does this. It's an inverted parabola, so it's going to have a value that is for k there, which comes out as negative. You'll notice that here we do not write y equals minus k x squared. The reason is the value of k will have to come out negative, but only when we put in certain values that lie on the curve. And when you do that, k will come out negative. So if you were to write negative kx squared here and then put in values of x and y that are on the curve, you're going to be having a conflict with the minus sign that you wrote in front of the k, which shouldn't be there. You will be getting another minus answer, and then you'll say, oh, well, k must be positive. Well, it can't be positive. This is an inverted parabola, so it has to work out negative. So do not write minus k there. Just leave it as k. Okay, so we're going to use the point 2 minus 2. There it is. It's sits on the curve to find k. So you put minus 2 for y, put 2 for x. 2 squared is 4, so minus 2 equals 4k. Cross multiply the 4 below the minus 2, and you're going to get minus 2 over 4, which is minus a half. So the full equation is y equals minus a half, there's k, x squared. There's been no horizontal translation and no vertical translation. So it is simply, it starts like that, but the value of k is minus a half, and it's like that. Okay, now you must be able to list the features of this parabola. Well, as I've already said, you give it its name. Its name is an inverted parabola. You must give the name. Do not assume that the person reading your work will say, oh, this person knows it's a parabola. Give it its name. Okay, it's an inverted parabola. It has a turning point at the origin, 0, 0, and that turning point must be a maximum. Now, what are the domain and range? Well, the domain is all the values of x. In other words, the graph, if I can get it back again, this graph here can be drawn for any value of x along the x-axis, any value of positive x, any value of negative x. It can be drawn. However, look at it here. It doesn't have any positive y values. So in other words, it only exists for the range, that is, for negative y values. And that's what I've gone and written down at the bottom here when it comes to the range. Now, you see these two little dots, they mean such that. So you would read this as the following. The range is all values of y such that y is less than or equal to 0. Less than or equal to because the graph can take the value 0 for y when x is 0. Okay? So in other words, it's only valid for all negative values of y, but including 0. Okay? So let's look at the other one, the next one, number 2, and see what we can deduce there. There we are. Now this time, unfortunately, you're playing with fractions, so you need to be good at playing around with fractions. This one, it goes through the origin there, and it goes through the x-axis there. And there is a turning point here at 1/2 minus 1/2. Now, we know it's a parabola, and it's a positive parabola. And so we can think of it as y equals k, x plus or minus 0, that's bringing out that point there, brackets x minus 1 for that point there. And of course, x plus 0 is just x. So this is the more grown-up way of writing the equation. Y equals kx, brackets x minus 1, close your brackets. Now we need to find k. Now, this is where it gets a little bit hairy with working with the fractions, but if you keep a clear head and do it slowly, you should be able to do this. So we're going to use this point here, which is 1/2 minus 1/2. And so we're putting in for y minus 1/2. We're putting in for this x 1/2, and for that x also 1/2. Now, 1/2 take away 1 is negative 1/2. Now, don't forget these brackets mean we are multiplying. So we're going to be going 2 times 2, which is 4, and 1 times 1, which is 1. So this comes out as negative 1/4. So if I multiply the k into that, I get minus k over 4. Well, minus k over 4 is equal to the y value of minus 1/2. So I've got I've got a minus sign on both sides of my equations. So if I was to multiply this side by minus 1/2, minus 1, sorry, and I was to multiply that by minus 1, then I've done the same thing on both sides of the equation, multiplying by minus 1, turning this into positive and that into positive. So then I'm easily able to cross multiply the 4 up there to get that, and 2 into 4 goes twice. So there is my positive value of k, which is what I expected, because don't forget what I said at the start, that this is a positive parabola. So it's no wonder that k comes out with a positive value. There it is, k equals positive 2. So your final equation, or your complete equation, is y equals 2x, brackets x minus 1. And talking about the features, we have to state its name, a positive parabola. We have to state the fact that it has a turning point at the turning point is a minimum, and the minimum is at minus a half minus a half there. Okay, now I've forgotten to mention some features here, and the features I've forgotten to mention are the intercepts on the x-axis. I should have said there's an intercept at 0, 0, the origin, and an intercept at 1, 0 there. The y-intercept is also the origin there. Okay, I think I've done that on the next examples 3 and 4. So that's a slap on the wrist for me, being a bit naughty. I forgot to mention the intercepts. Anyway, the domain again is all of the x-axis. Let's look again at the graph and see what that means. It means that we can draw this graph for any value of x in the negative direction and any value of x in the positive direction. However, it's not this case with y, the range, this one here. Y's values only kick in from above negative a half. The y value can take the value of negative a half at that point there, but there are no bits of the graph for y values less than a half down here. Okay, the graph only starts above -0.5 for the y value, so that the range can be written like this. Here it is valid for all values of y such that y is greater than or equal to -0.5. Okay, all right, now I'm going to do one more video for questions 3 and 4. So that's it for these two here. Okay, bye bye.